Here we consider inequalities with absolute values, and we have to be a little careful here because we have to separate the cases where we have negative values inside the absolute value sign from the cases where we have positive values inside the absolute value sign. Remember that the absolute value of x is x if x is positive and negative x if x is less than or equal to 0. This means, of course, that minus 4 is less than 1, but its absolute value is 4, which is greater than 1. And so it's exactly this point that we should think about when we're solving these inequalities, and we should separate our analysis into cases accordingly. So we should consider the cases of negative values and positive values separately when dealing with these inequalities. Below we show a chart which shows the solution to these very basic inequalities: the absolute value of x less than c, less than or equal to c, greater than c, or greater than or equal to c, where c is some constant, some real number greater than 0. And we see that if the absolute value of x is less than c, then this is the equivalent form, but it's also a description of the solution. The solution set is all values, all real numbers between minus c and c. You can see this fairly clearly if you think of, say, c equals 2. The absolute value of x is less than 2 includes all numbers between 0 and 2, but it also includes all numbers between negative 2 and 0. So it includes everything in the interval from minus 2 to 2, and we have less than here because we have less than in the inequality. The endpoints are not included, but if you had less than or equals in the inequality, the endpoints would be included. On the other hand, the absolute value of x greater than c involves two separate subintervals. It's the union of all x greater than c, which obviously satisfy the inequality, but this inequality is also satisfied by all x less than negative c. So the solution here is the union of these two subintervals, x less than c, x less than negative c, and x bigger than c. And you have a similar thing going on if you replace the greater than by greater than or equals. Now we can apply this to a situation where we have an inequality of the form the absolute value of a less than c or greater than c, where a is some expression, some algebraic expression in x. So this means that the absolute value of a is less than c if a is between minus c and c. In other words, if minus c is less than a and a is less than c. So we can translate this inequality into a pair of simultaneous inequalities, and the solution set to this is the set of all x which satisfies both of these inequalities. We have a similar situation if we replace less than by less than or equals. And on the other hand, the inequality the absolute value of a greater than c, its solution includes all solutions of the inequality a less than negative c, and it includes all solutions of the inequality a greater than c. So in order to solve this inequality, we solve both of these inequalities, a less than negative c and a greater than c, but they're not simultaneous inequalities. So the solution set to this is the union of the solution sets to these two inequalities. So we have to be a little careful. For the absolute value of a less than c, we have simultaneous inequalities, and the solution set is the intersection of the solution sets of these two inequalities. And for the absolute value of a greater than c, we get two inequalities, but the solution set is the union of the solution set to both inequalities. So let's do a couple of examples. This one is typical of what you encounter in Calculus 2 when you're working with power series. And if you want to solve this, we can apply our usual algebra of inequalities. So we can multiply both sides by 2 here to get the absolute value of x minus 3 is less than 8. Now we're in a situation which is comparable to the top line here. We're looking for the solution set to the absolute value of x minus 3 less than 8. Some expression in x, its absolute value less than 8. Now, if you think about this, this is really just saying we're looking for all x whose distance from 3 is less than 8. So you should already be able to tell what the solution is. We're looking for all x values on the real line whose distance from 3 is less than 8. So take a guess at what the solution is and see if it matches what we get when we apply this analysis. Well, according to this analysis, this gives us two equations. So we must have minus 8 less than x minus 3 and x minus 3 less than 8. We can separate that into two inequalities if we like. And our solution is the set of all x which satisfies both. Now minus 8 less than 3, I add 3 to both sides and I get minus 8 plus 3 less than x. And I add 3 to both sides here and I get x less than 8 plus 3. So my solution set is the set of all x, so that minus 5 is less than x and x is less than 11. Or minus 5 less than x, which is less than 11. And it's the interval not including minus 5 because we have strictly less than minus 5 to 11 and not including 11.